All right. Hello, AB. Time for another video. So we're just in the section 6.2, and so I am going to continue on with that. So we have talked about the fact that the definite integral computes area, and we can also use area to compute a definite integral, and that's what we're going to do right here. Okay, so this is asking us to find the integral from 2 to 4 of 2x minus 3 dx. And we don't really know how to manage that right now, but we do know how to manage finding the area under curves from geometry. So we are going to sketch f of x equals 2x minus 3 from 2 to 4. All right, so from 2 to 4 here. So we're just going to plug in those 2 points. This is linear, easy peasy. When I plug 2 in here, I'm just going to plug in those endpoints. When I plug 2 in there, I get 1. And when I plug 4 in there, I get 5. Okay? So 2, 1, and 4, 5. 2, 1, 4, 5. All right, there you go. Lock it down to the x-axis. Let's do the area under the curve, and we'll answer the question up here. The area under the curve will be the definite integral. So this is a trapezoid, 1/2 base times height. So we have 2 bases here. So let's just talk through that a little bit. So we have 2 bases here. First we think of this as the base in, as kind of, standard base. But for this trapezoid that's sort of on its side, this is going to be the base and this is going to be the base. So it's going to be 1/2 the base times the height, but it's 2 bases. So we'll get those there, and then the height is actually this, the height of this trapezoid is actually this 2. All right, and so this height is 1, and this height is 5, but those are really the bases. And so the area of the trapezoid, of course, is 1/2 b1 plus b2. So it's just like the triangle, 1/2 base times height, except there's 2 bases, which look like heights. Anyway, so this here is 1/2, 6, 2, and so this is going to be 6. This definite integral computes to be a number, and that number is 6. All right, next one. So this is a graph of a semicircle. And so, where does this come from? If this is the function y, 16 minus x squared, let's square the y, square this side, move the x square over. So that's a circle of radius 4, and if you went backwards with the square root theorem, that'd be plus and minus, but it's just plus, so this means the top half of a semicircle of radius 4. Okay? So that's a curve that we lock down to the x-axis. And so I am doing this f of x here from -4 to 4. All right, so what is the area under this curve? Well, it's going to be 1/2 of the area of a circle, because it's a semicircle. So it is 1/2 pi 4 squared. So it is 8 pi. All right, 8 pi it is. So we're using geometry areas to calculate definite integrals. Okay, so looks like I have another line here. So let's go from 2 to 5, 2 to 5. Okay, so when I plug in 2 there, I'm going to get, 0. When I plug 5 in there, I'm going to get -6. So 2, 0, and 5, I'm at 1, 2, 3, 4, 5, 6. Okay, so like that. And we compute areas locked to the x-axis. And so this is 1, 2, 3. Okay, that base there is 3, and this is 1, 2, 3, 4, 5. So this is -5. I hate to label the side of a triangle with a negative value, but I want to compute correctly. So I'm going to go ahead and do that with a negative. Sorry, with a -6. I counted wrong. Sorry, with a -6. Friday afternoon. Let's get it together. Okay, so this is going to be the area of this line. We're going to go from 2 to 5. So this is 1/2 base times the correct height of -6. Okay, and so we are going to get 1/2 of 18, which is -9. All right, so this number is negative 9. So that is a little foreshadowing of what's going to happen when we are under, not a positive function, but when we're under, we're going to get a negative area, and that's what happens here. So all values of f of x are negative, okay? So the Riemann sum is also negative. And that's going to be the case with negative, that'll be a negative area when it's underneath the x-axis. All right, let's graph this again and now go from 0 to 5. So at 0, I'm at 1, 2, 3, 4. All right, and at, just a little t table here, 0, I'm at 4, and then at 5, I'm at that negative 6. Okay, and so we saw before that we were going through the x-axis here. So I've got some positive area and some negative area. So I've got this positive area and I've got this negative area. So I'm just going to do two geometric formulas here. Okay, I'm just doing f of x is this line from 0 to 5. All right, so the one area is going to be 1/2. This base is 2, this height is 4, okay, which is 4. And the bottom area is 1/2, so that's 2 by 4. And this is 1, 2, 3 by negative 6. And so this is 1/2 again, negative 9. Okay, so this area then is 4 and plus a negative 9, so this area is negative 5. There's more negative area there by 5. Okay, so here we are in calculus doing geometry. It's a beautiful thing. Okay, and so here we go, a couple of things here. So if f of x is below 0, then the integral, the definite integral, is negative. Or kind of the opposite of the kind of the area, the absolute value of the area, it's the opposite of if you just to continue this triangle, not on a coordinate plane, just this triangle area would be 9, and then if it's below the x-axis, it's negative 9. Okay, so shade the three regions here between the curve and the x-axis, use plus or minus to indicate the concept. So you would lock down to the x-axis, lock down, this is a positive region, this is a negative region, and this is a positive region. So in general, the integral of a to b of f of x dx is the area above plus a negative area, or you would just say minus the area below, and the area below, as a positive. So you could either say the two areas added up, writing this as a negative, or if you want the negative here, it'd be the two kind of positive areas, just as an area in geometry. All right, that's page 1. Let's see, what do we have going on over here? Okay, we've got some absolute value, and we're going 4 to negative 4. Okay, so there we go. You could just go from 0 to 4 and double it, because you've got some symmetry going on here, but I'm doing absolute value from negative 4 to 4. All right, and so my areas are 1/2 base times height. All right, so that's this over here. So there's 1/2 of 16, which is this 8. And we can just double that. That's 8. That's 8. This is an area of 2 at 1/2 base times height, 16. Okay, and that's the integral. The integral is a number. The integral is 16 there. So this next one is a constant, 1, 2, 3, 4. And let's go from 2 to 5. Okay, there's that graph. Lock it down. Okay, and so this constant, this is 4 then, and this is a span of 3. So yes, we are multiplying 4 times 3 to answer our calculus question here. This is a constant. We are going from 2 to 5. And so this area is 4 times 3, which is 12. So I have a little conclusion here. If f of x is a constant, where c is a constant, okay, then the integral from a to b of this constant dx is just that constant times the span of the interval. All right, so y equal to c here, and you just are going b minus a is this, base, and this c is this height or width and length or whatever dimensions you want to think of. Okay, so this one we're now moving into equations. We're now moving into x squared. So we know that this is x cubed over 3 plus c at this point, but what do we do with this 0, 4? We don't know that yet, so this has to be given to us right now. So they're telling us that this is 6 over 3. All right, so basically if we are looking at x squared from 0 to 4, okay, at 2 we're at 4, at 4 we're at 16, 1, 2, 3, 4, 16. We're looking for this area. And they're telling us that that's equal to 16 over 3. So we really didn't have to do anything on this problem except draw it. Okay, so just a few little, changes. So what happens if I go from negative 4 to 4? Well, you're going to see we're going x squared now. We're going to double. But you can probably guess what's going to happen here. 1, 2, 3, 4. You've got some symmetry. 1, 2, 3, 4. Symmetry. It's a parabola. Well, I guess if we're going by 2s, that's got to be here. Did I do that over here? Yeah, okay, so this has got to be over. Doesn't really matter. 2, 4. Okay. And so 2, 4. All right, again, this is at 4, 16, negative 4, 16, 1, 2, 3, 4. Okay, and so now we've got 2 of these. So look what happens. We've got negative 4 to 4 on something that's symmetrical. We can just double the area. So we can just double 64 over 3 and get 128 over 3. All right, and so, we're here. We need to just double this side. And if you're ever asked to do this, you can just split the integral and, instead of going negative 4 to 4, you could just go 0 to 4 and then double it at the end to make your life easier. It's always easy to involve a 0. All right, let's see what happens now. Oh, now we're going to shift it right. So let's take x minus 1 squared from 1 to 5. Okay, so this is good. You want to look and make sure you got some consistency here. So this is a right shift. This is right 1. And so by my given, I got to make sure that we're looking at a shift right 1 from the lower bound and a shift right 1 from the upper bound. So 4 shifted right is 5 and 0 shifted right is 1. So that is good news. That means it's going to be consistent with this given. So all that's happened here is we have just taken this over here by 1. Now at 5, I'm at 16. So over 5, now I'm up at 16. And instead of at 0, 0, I'm at 1, 0. But just imagine pushing that chunk of area, it just pushed right. So the value of the area under the curve didn't change. It just did a nice slide right. So this is still 64 over 3, just right 1. So just imagine pushing this right 1. The area doesn't change. It just kind of slid. Okay, but now on this one we're going up 2. So these bounds are talking about your left and your right. So if I go up 2, this should not change. I don't want this to change. So now I'm just going to take this block of matter, if you will, this area, and push it up 2. Okay, so instead of at 0, 0, I'm going to be at 0, 2. Okay, and instead of at where am I? Where's my original? At 416, I'm going to be at 1, 2, 3, 4, 418. Okay, so it's going to look something like. All right, so let's label that 0, 2, 4, 18. Okay, so this is x squared plus 2 from 0 to 4. Okay, so how did the area under the curve change now? Well, this block is still the given, 64 over 3. But I'm not locked down to the x-axis. I've got to account for this space right here, this little kind of like it's on a pedestal or on a stand. So I've got to account for this. So I've got to add in 1, 2, 3, 4 by 2. So this rectangle underneath is 8. So when you have a vertical shift, you've got to do that. You've got to do 64 over 3 plus 8. So 64 over 3 plus 24 over 3, or 88 over 3. Okay, so that is page 2. Okay, I'm going to do this next page, and I'll split this into two videos because it's kind of lengthy. All right, so this next page, let's warm up finding integrals by signed arrows. We're just going to do this. So sketch the graph of sine of x over the interval 0 pi without using your TI. Shade the region between the curve and the x-axis over 0 pi. Okay, so it's telling us, given that 0 to pi, this is going to be an area of 2. Okay, so remember our sine curve. This is pi over 2. That 1. Just a little portion of the sine curve. And this is of area 2 given. All right, so let's use these properties. Okay, so what happens if I just go halfway? So what happens if I go here and just go to pi over 2 and stop? Well, due to the symmetrical nature of sine, then this will just be 1. Okay, that will just be 1, half of the given area, half of 2. This is 2, this will be 1. Okay, what happens if I go here? Again. Oh, shoot. What am I doing? Doing it wrong or something. Okay, down here. Okay, so this will be like this. All right, so now I've gone from negative pi to pi, so I know that this is by the given 2. And then over here, again, the sign is odd. It's got odd symmetry. This is symmetry with respect to just that 0 to 1 to 0 is symmetrical, you know, from the quadrant. Basically, if you're thinking of quadrants 0 to 90 and then 90 to pi, that's going to be symmetrical on the curve. But this is odd symmetry, so you're going to be rotating around the origin. So you're going to have this piece above and this piece below. All right, so this is negative 2. And that would be area of 0. Okay, let's go over here. So then again, so what if I went to pi over 2 and negative pi over 2? Okay, so this would be here to here, here to here. Sign's going up, lock it down. This would be 1. Sign's going down, lock it to the x-axis. That would be negative 1. Okay, and so we tally those up, and due to the fact that it's odd symmetry, 0. So in conclusion, any negative k to k, these have to match. Due to odd symmetry, this would 0 out. Odd function. For any odd function. Sine is odd. Odd symmetry. And I guess I could call that origin symmetry, not odd symmetry. Origin symmetry. Odd symmetry would be with respect to the origin. Okay, so this next one here, let's do this absolute value of sine. And this is where I was heading on this one. So if you take the absolute value, you're going to go like this. So this negative will flip up. That. Okay. So negative pi over 2, negative pi over 2. So this is 2, area of 2. And now this is an area of 2, absolute value. So this would be 4. All right, last couple ones. All right, what happens if we multiply this by 3? Okay, so 0 multiplied by 3 on the vertical would still be 0, 0. Pi 0 multiplied by 3 would still be pi 0. because you multiply 0 by 3 and you still get 0. And then this pi over 2, 1 times 3 would go up to 3. So this just has an amplitude of 3. Okay, not the best little curve there, but that's okay. This is pi over 2, 3. And so that's just going to be 3 times the area, the original area. And we can factor out this 3 if that's helpful. You can say that this is 3. You can factor out scalars there. 0 pi, scalar multiples. So this is just 3 times the 2, which is 6. All right, and then our last one here, let's shift it up. So we're going to shift this sign up. So this 0, 0 is going to go all the way up to 0, 2. This is going to go up to pi 2. I'm not writing 0 again. Pi 2. And this is going to go up to 4. Pi over 4. All right, so this area right here is the given 2. And so then we just have to assess this additional area, this gap here. And that is going to be a span of pi by 2. Okay, so that is pi by 2 or 2 pi. Pi multiplied by 2. Okay, so this was given. And this is just this whole thing is pi. And this whole thing is 2. So 2 plus 2 pi. Okay, so that's the first part. The first part of the rest of 6.2. Okay, I'm going to sign off and start a new video. All right. Bye, guys.